My partner here is Miguel Elias Robles, and my name is Thomas B. Ricker. We hope to entertain you for the next 45 minutes plus Q&A. Okay, let's start with a small overview of the lecture. We'll just point out some basics. Sometimes we won't even go in depth, just point out what you should check to understand the further topics. And then we'll start with wartracking itself. It's just some history, what was in the past, what were interests on satellites in the past, what was interesting, then present, which is more or less, we said 1985 to now, just to make a difference to the past. And then we'll consider what will be the future of satellite communications, what is interesting, what can we expect. And then we'll go on to hands-on wartracking. That's more the practical part, looking at what you can do actually, what you can listen to, that's passive, and where you can actively use satellites legally and illegally. That's the next point, legalese. What are legal implications of passive or active use? And then we'll end up with the Q&A session. Okay, so let's start with the basics. What is a satellite? A satellite is an object circling around another object, as opposed to objects that leave the circle around the object. That would be like Mars Explorer. That's not a satellite that left Earth orbit. Orbit is the path around the planet in that case. A geostationary orbit is a special case. The basic point is it's a very interesting orbit because you can use it for communication satellite. If you look at a satellite from Earth, it appears as if the satellite wouldn't move at all, because it's more or less moving around the Earth in the same speed, the same angular velocity as Earth turns. So every 24 hours it circles around once, so it seems to never move. Okay, ecliptic, another element. We'll just speed it up a bit. Keplerian elements is a thing you will be needing afterwards, after this lecture. That's the sum of all relevant variables of an orbit of, for example, a satellite, to know where it is. You can feed those Keplerian elements into a specialized software, and then it will tell you that the satellite is exactly over there. And then you know where to point the antenna or where to look. Some satellites can be seen from Earth. The most famous is the Moon, of course. Payload. Payload is, that's what we are basically interested in. That's the part of the satellite that is active, where, for example, the TV program is relayed from orbit back to you, to your home, to your satellite dish. Frequency bands used for satellite communications are, for example, the most used TV band is around 10 to 12 gigahertz, that's the Q band. And there's also C band around 40 4 to 5 gigahertz, more or less. You can find all those informations easily, for example, in Wikipedia. So it is not necessary to cover them here and now more. The transponder is a thing we should mention too. It's well, of a logic element of the beam coming down from a satellite, for example. It's a part, a frequency band, where a special information is contained. For example, a TV program, or with DVB, a digital video broadcasting or digital data broadcasting. It's the complete multiplex containing all TV, radio, and additional data. Okay, so much for that little basic introduction. And now we're going on to in medias res, to go to the past. That will be covered by my colleague.
Well, the first satellite, it's Sputnik. It was launched at September 1957. It was nothing else than a radio transmitter in 20 and 40 megahertz. It's really low in frequency, and it was really fast. It had only 6 hours, I think, to take around the whole world. And he only transmitted temperature outside and inside of the satellite and the pressure. Historical, you remember the Americans had a shock. Well, they said, they launched a rocket and they had the satellite on in orbit, and we can't, and why it doesn't. And the important thing in this is they launched the Sputnik with a standard atomic bomb ACBM rocket. So they show with this satellite that they can arrive with their rockets America, and this was the important thing. I have a little audio recording of the sound of the Sputnik. Oh, sure. This was what you heard, 1957. This was temperature and something like this. So you can, on this frequency, you can hear it with a standard AM radio. So anyone in the Earth, and the moment the satellite overflow you hear this sound in the frequency of 40 and 20 megahertz. So anyone know that the Russians had a satellite above your head. Well, GLONASS. GLONASS was a satellite systems. They use it for reconnaissance, like they can make photos, really sharp photos. They said it was more for weather satellites, but I think no one believed it. The thing is, the last GLONASS satellite, 945, hit the ground and Canadian ground. So they found out they had an atomic reactor in it. So Russians shot satellites with atomic reactors in the space, and they didn't know that the satellite hit the ground. The Canadians called the Russians saying, "We have something from you." USA. Well, the first telecommunication satellite and, well, telecommunication and television satellite was a Telstar. It was something like a ball, nothing bigger than this. It was really unstable, and to make a connection, well, the American president wanted to make a television transmission to France. They had only a half an hour because the satellite overflew the Atlantic, a half an hour, and after this half an hour, it hasn't more. The satellite was anywhere, but not in Atlantic. And the funny thing is, it was really unstable. It was a ball, it making everything, but so this was the first video transmission from USA to France and from France to USA. Not really good. They had problems with NTSC signal. Never the same color. Well, something different, isn't it? NOAA. I think you know more about the NOAA.
Well, the NOAA are satellites, are basically some weather satellites by the NOAA, and they provide, for example, weather pictures and other things. Well, that's just to give some idea what's up there. There are other satellites like the GPS satellites by the US and things like that, and also other countries had their satellites too, military or civil use. For example, well, go on.
Well, the next country was France. France was one of the successors of Russian and USA. They sent the first satellite from Africa, I think. It's nothing special. They only had the satellite only was for to saying we have also a rocket that can reach the space. Japan was after France taking the first communication satellite for Asia. Well, Americans had the satellites, but they reached Japan, but that doesn't had Japanese programs. Germany had launched with the ESA some satellites, and UK. This is something special. They launched many satellites, but only with well, one of the satellites was launched from a submarine, and because they had the rockets in the submarines, and so it was possible. Present communication satellites. Your turn.
Okay, thank you. This is telecommunications satellites in the beginning of the period we took as past, that's 1985, were basically phone lines and television lines for transatlantic transmissions. For example, many phone calls were dispatched that way, and that was a very interesting period because all that comes with just multiplexed analog signals, so it was really easy to listen to that stuff. That was really interesting. You could find some really interesting information there. This is still true. There are satellites, for example, Arabsat, operating in the C-band, visible from Europe. You can receive it with around 1 meter, 1.20 meter dish with a low noise block amplifier for the C-band. And well, there is a transponder you can tune into, and you'll find there are still plain phone lines there, and you can listen to phone calls, trace them, see who called whom, and there's just plain in-band signaling by DTMF, and you can listen to fax transmissions. So that thing's not dead yet. Another analog communication satellite system that is not so much for video but for phone lines is Inmarsat A. That's still also an analog system. There are the successors Inmarsat B and C. Those are more advanced, but the old system is still in use, and well, you can listen to interesting things there too. Well, then there were, of course, the military and intelligence satellites, also pointed out by my colleague, that was intensified in those years, and there were also interesting transmissions there that could be even seen with just normal home TV equipment. You had just turned the dish a bit around. For example, there was a satellite placed more or less above the Atlantic Ocean, and during the war in Yugoslavia, the US military just booked some transponders there. The US military is famous for outsourcing many things like communications, and the outsourced partner just bought some plain transponder space for TV transmissions, and well, someone accidentally tuned to that transponder and saw things like reconnaissance planes flying around Yugoslavia, observing suspicious places, and it had also some communications there. Well, there are sources for that. It's even covered in books. You can read on about that. We'll place information about where you can find this on the website. The URL will be provided at the end. Okay, so the more interesting things, UFO and fleet.com. UFO is just an acronym for what was it? Sorry, I forgot, but it's the communication system that was basically brought up very shortly before the first Gulf War. The Bush administration, the first Bush administration, had said, well, okay, we need a communication system for our armed forces, for an external mission, for a war now. Well, I think they asked Boeing, okay, you have 2 months, give us satellites in orbit. Well, 10 pieces or so. Just give them. Well, they had no time for real security. It's just plain old bent pipe repeaters. It's just, you can point a directional antenna at the satellite and listen to communications. They are mostly plain narrowband frequency modulation. Well, you could even send narrow frequency modulated signals on the input frequencies. That would certainly work. Later on, a bit more about that. No. Thanks. Some more. Echelon. Echelon is mostly referred to as being a ground-based system. There are also some satellites in orbit that are quite huge and have quite big possibilities and capabilities. There is information on that. We don't have the time to cover that, but you can visit us later on or look at the site. We will have some information for you there. They have really big things in orbit that have really big ears. Okay, Skynet is just the British version or the Italian version. Well, there are also other military nets, of course. Brits have their own, Italians have their own, Russians have their own, and Skynet is one of those. If I recall correctly, that this one has also some lower frequency, easy to use comms, but that's not so much wide known. Okay, of course, those military satellites have also not so easy to use transponders, but later on a bit more. Okay, so now we'll have to also cover the scientific satellites. For example, Meteosat, one of the more known satellites that's just providing, for example, weather images. Or the infamous Cryosat that, well, had a cold encounter around the North Pole. It didn't make it into orbit, sad thing. Okay, so let's leave that and see for the future. What does the future hold for us? Well, everything's going broadband at the moment. Broadband also at home in your DSL lines, but also into orbit. Broadband broadcast. A bullshit word for that would be HD TV and things like that. Well, maybe it will prove useful, but that's what we have to expect. There are new standards deployed at the moment, and analog comms are being phased out since some years, and they will cease to exist in the very near future. You can look at the channel lists on the set pages like linksat.com and see there are not very many of those analog transponders left. What really might be a next big thing is mobile individual communication. It has been there for some time, but it was very expensive, and it's not yet there. But it really can be a thing like convergence between the normal based terrestrial systems that are like GSM or UMTS or Edge, and for areas where there is no coverage, there probably will be mobile individual communications based on satellites. Also, this will be used for, well, is used also for communications on sea or for tracking containers, for example. That's based on a mixed thing like GSM, GPS, and other communication modes to track where is that container at the moment exactly. Because it really happened that containers just disappeared in the past. Okay, an interesting thing we think will happen is forgotten satellites that will prove to be, well, still able to work. If accidentally, for example, a transponder is left on, you could easily use it for your own means. For example, an old satellite that is no longer actively maintained, that is no longer bringing much money in for the company that shot it into orbit, is also not very actively monitored. So that could mean that you can slip some things through just on the side. Okay, so much for that more theoretical part. Now on to the hands-on thing. Well, there are the passive parts, the active parts, and the legal parts here. Now we'll cover the passive parts. You of course need some antennas that can be dish antennas like for TV, or Yagi-Uda antennas, or logarithmic periodic antennas. Some very easy to obtain. Just go into a store downtown and buy an DVB-T logarithmic periodic antenna, and you're all set to to, for example, listen to some fleet.com. Modulations used on the interesting things that are easy to listen to are mostly narrowband FM modulations. So receivers are not that hard to get. Things sometimes proving more difficult are the low noise blocks and some modulation hardware if it's more advanced. But things can be organized, can be bought. It's not that hard to get that stuff. Examples here for the easy stuff is weather satellites. There are downstreams on around 130 megahertz that can be easily listened to. That's easy for your first steps into satellite listening. A thing also quite often mentioned is the DVB IP broadcasting, Sky DSL and other things referred to. Well, there is a promiscuous mode, of course. You can listen to all that stuff flowing down from the orbit. There was a lecture on that yesterday. I'll mention it once again in the legal part because I think it's important to do that. Analog voice traffic, as mentioned before, for example, the UFO satellites, etc., is not very hard to receive. Just normal scanner hardware covering frequencies up to 400 megahertz should fully suffice. Well, another thing sometimes neglected is ground stations. You can certainly look directly at ground stations. You don't have to look at the satellite itself to see some satellite communications. There are ground stations everywhere nowadays. The big ground stations, for example, Echelon, Bad Aibling, moving to Darmstadt, Griesheim at the moment, or the less known near Frankfurt, Usingen, German Telecom ground station providing international satellite communication feeds and stuff. You can point an antenna at those dishes and easily you will listen to what is sent into orbit. That's often forgotten. Just to mention that. Okay, so go for the active part. I have to mention there's a legal and an illegal part here that's very thin line to cross. At least you'll need some modulators to create a signal. The easiest could be modified amateur radio transmitter. You'll need some power amplifier, that's what the PA stands for, to produce the sufficient high frequency power to send a signal to the satellites. Of course, you'll need an antenna for that frequency too. Examples to work here, to actually work, are the fleet.com satellites. If you listen to those, you'll sometimes find, for example, South American party lines, people chatting, definitely not military traffic. Well, it's a cheap phone line, I'd say. You just need a transmitter and a receiver. Not very much done to prevent this. Well, the satellites have almost no means to prevent this. You could fool with, you could, of course, fool with the Inmarsat satellites, especially with the Inmarsat A satellites. As I mentioned before, some satellites are not that actively monitored anymore. You could try to slip in some signals. Another thing that is theory but could well be possible is sometimes the transponders used for telecommunication satellites for DVB broadcasting. The transponders are basically a bit wider than the signal itself. So you could have the possibility to slip in a small signal nearby. That would have been testable. I don't know if anyone managed to do that, but certainly an interesting thing to do and research. A very common way to be your own satellite broadcaster is amateur radio satellites. There are satellites that are really not commercial satellites. They were brought into orbit by community effort, radio amateurs, and they can be used absolutely without problems, sometimes even with very, very low hardware recommendations. For example, a amateur radio handheld transmitter sometimes even works. You just have to go outside if you know the satellite is above you and press the send button and talk into the air, and you'll have some nice communications. This really works. I've tried it before. Yeah, there are also some more advanced amateur radio communications. You'll find information on that too later. Okay, now on to the legal stuff. Well, the active mode is very often illegal. For example, in Germany, that would be interference with commercial interest. That could be, for example, in case of slipping in broadcasting IP information into the DVB stream, as covered yesterday in a lecture. That could be, the German word would be Erschleichung von Dienstleistungen. That's also a thing that can be prosecuted. Well, I'll rather not do that. It could prove very expensive for you if they find out who did that. Well, abusing commercial satellites, that's what we covered in the active point mostly, is, well, it's misuse, and it's mostly not legal. It's often causing interference to the things that are already there, the normal transmissions. Well, the really best way, I have to admit, to stay legal if you want to actively play with satellites is amateur radio, because if you own an amateur radio license, you really are allowed to do satellite communications with amateur radio satellites as much as you want, as much as you can. Well, so much for the legal part, and now on to the questions and answers section. We know this was really a short and quite quick walkthrough on that topic. It's a very complicated and big topic. We're happy to answer questions now and also later on, or by email. We can be reached easily. Okay, now questions, please.
Okay. How can I find out when a satellite is overhead so that I can talk to it or can listen to it? Is that what these Kepler elements are for?
Yeah, that's what Keplerian elements are for. There is software available for most platforms. Linux also. There are Java implementations of prediction software that you just have to put in the Keplerian elements. That's just 2 lines, mostly 2 lines of data. Sometimes the software even downloads it itself from the internet, and then it tells you, okay, this on the time based now, the satellite is there. Does that answer your question?
Yes, thanks.
Okay.
What are the chances and methods to get tracked when you're actively playing with the satellite?
Well, that's a very interesting question, I have to admit. That fully depends on what you do. If you play with low power and not easy to track frequencies, that might slip through easily, but there are really also technical ways to find out where you were broadcasting from. I'm not very familiar with that, but I know there are, for example, special satellites in orbit that can be used to track your position, but also ground stations that could, for example, receive spurious transmissions from your transmission setup.
Thanks.
I wonder if you could talk about Thuraya and the security of their communications. They say that it's comparable to GSM, which seems kind of funny. And a couple of other questions.
Well, okay. I've seen and used Thuraya phones, but I only can tell you what you all already said. It is using actually GSM SIM cards, like some other companies too, and it could be really interesting to research that topic. But the communication itself between the phone and the satellite is probably more or less safe.
What kind of hardware would you suggest for automated tracking so that you could do some sort of programmable sweep of the sky?
If you want to track not only the geostationary satellites, but satellites that are moving, you'll need azimuth and elevation rotor. That means an antenna can be turned once around and also from 0 to 90 degrees in the angle. And you can either build it yourself, depends on the size and weight of the antenna. There are azimuth elevation rotors for radio amateur use. That might prove not that expensive, or you can buy commercial ones that would be priced around 1,500 euros, I think, but they are very heavy duty and very good. It's a company called Aegis, if I if I remember correctly.
And about Inmarsat, you talked about Generation A. What about their always-on data terminals, and what kind of cryptography are they using? Have you monitored them at all?
Well, I haven't been playing with Inmarsat myself. I've just read and talked to people about that, and it's just based on my findings, what I was talking to people that have researched Inmarsat.
Thanks.
Okay.
You talked about the thing you used and you tried in experiments.
Yeah.
It was like telephone communication or voice communication. What is about information communication? Is it able to do kind of data communication, for example, with these amateur satellites, which is free to use?
Yes, certainly. You can use amateur radio satellites for data communication. And very famous example for that is the International Space Station that is carrying some amateur radio payload. Mostly it is in a mode called APRS, that's Amateur Position Reporting System. You can broadcast your position with that system. It is a baud rate of 1,200 baud, more or less. and the uplink is at 145.8 megahertz, and the downlink is on 70 centimeter band. That's somewhere around 430, 440 megahertz. I would have to look it up. There are also other satellites that carry mailboxes. You can use them to relay messages. This was, for example, used for relaying messages between America and Europe for some time. And a thing really to mention is this is no real big bandwidth you can expect. And another thing is you can't use it for purely private communications, and you can't use encryption in amateur radio. So it's not you can play with it and have private conversations between you and someone else encrypting the path. Amateur radio is a mode that is public by definition. Does that answer your question?
Not really. One thing more. Is it possible to make a TCP/IP connection over satellites, over these satellites?
Yes, but it will be very slow. As I pointed out, the data rate is about 1,200 baud, and it is possible to work IP on that.
Thanks.
Have you looked into combining your setup with software radio technology, or
With what technology?
software radio technology for demodulating?
Software radio. Well, software radio. Well, yes, it can be used. For example, if you have an intermediate frequency that can be listened to by a software-defined radio. Most software-defined radios I have seen mostly cover only shortwave frequencies and also need further intermediate frequencies, of course. Well, you can use that, of course, and it will certainly work. For example, an interesting thing would be to use a software-defined radio to look at the before-mentioned C-band transponders on Arabsat. You could see all phone lines at once. Well, maybe not all, but at least a few of them. Further questions? Okay. Another question, yes?
What is known about denial of service attacks on satellites? Is there any case known to you where people were involved in trying to bring down commercial service for a certain period of time?
Yes. For example, the Iranian government is trying to jam TV satellite transmissions by sending jamming signals on that frequencies. It is possible to partly prevent that jamming by shielding the antenna entirely with a cage, just to leave an opening towards the satellite. That mostly helps with that. There also have been attempts to, just jam input on broadcast satellites. I've talked to someone who he was a normal broadcaster, and they forgot to call the satellite company that they were actually going to send something now to their base, and they turned on the signal on that transponder, measured in, and after around 20 seconds or so, they had a real big jamming signal on their transponder, preventing any transmission. Well, satellite maintainers are watching all the time.
And what would they do? How could they shield a satellite when it's already in orbit? They couldn't. They would have to put something else in, so you could only transmit from.
Are you referring to the Iranian?
Yeah, for
problem?
example.
In that case, the Iranians are trying to set up more or less a virtual satellite on a hill that is seen from the same direction as the satellite. So they are pointing a strong 10 gigahertz transmitter at their own country, more or less, and trying to jam that frequency band by that. If you really narrow down your reception channel by enhancing your antenna, by shielding, for example, by putting up some wire mesh shielding to the side of the antennas to prevent signals coming in from the sides, you can prevent that jamming. That's covered in literature too. You can look it up at our place upstairs if you want to.
Thanks a lot.
You're welcome.
Let's get to the good stuff.
Okay.
What about the command and control channels?
Okay, the command channels. Well, that's a real hard thing. I'd say it is certainly possible to run a denial of service attack against satellites. That's no problem, really. You just need to find out the control frequency and send up bogus data for some time, and the satellite will go into single mode and won't listen to any control codes for a certain period of time. Certainly hard thing to accomplish would be sending your own control codes.
Yeah.
That's what we're all interested in, aren't we? Well, I haven't researched that topic, I have to say, but as far as I know, they use evolving codes, and it's not that easy to crack that stuff.
Okay.
How about the security
Yes.
with commercial television satellites like Astra? How do they secure their uplink?
How does commercial satellites, broadcasting satellites, secure their uplink? Is that the question?
Yeah, and if you may perhaps point out the example of the Falun Gong hack. that happened some years
What
earlier.
example?
I heard that people from Falun Gong were actually able to broadcast over satellites in Asia somewhere.
Yeah. It is, well, as I said, some satellite companies monitor their satellites closely, some not that closely, and that probably was a combination of running a denial of service attack against the satellite plus taking over a transponder. For example, they found an open transponder, or they just jammed or had a stronger signal than the normal signal on that transponder, and simultaneously jammed the control channel so that the satellite broadcaster could not, for example, turn off the transponder. That's a way to work with that. That could be what it was, more or less. But most satellite companies are well equipped for that cases. As I mentioned before, the in-field engineer had a real problem after sending 20 seconds or 30 seconds of video. Okay, there's a question over here.
There are various commercial IP over satellite solutions. I was just wondering whether this data stream was just in the clear or encrypted somehow.
Well, sorry, what was your exact question about that IP broadcasting?
No, there are commercial
Yes.
internet access through satellite
Yes.
offerings.
Yes.
Are these data streams usually encrypted on the link level, or is it just clear IP?
Well, as pointed out in the lecture yesterday, it's mostly plain MAC security. Receiver cards have MAC addresses and mostly work just listening for their own MAC address. You can run them in promiscuous mode. This can be seen illegal in some countries already. Not sure about Germany, don't know. But there are interesting pieces of software that can be run on that. For example, I imagine it would be real fun to run DriftNet on that, just to watch images flowing down from orbit and things like that. Okay, I think we'll leave some minutes for the next lecture to set their computers. And if there are any questions left, please feel free to visit us upstairs on the second floor, and we are at the CA third stand. We'll also provide some internet address where you can visit. At the moment, there are only the slides from the lecture at the moment, but we'll provide some additional information like bibliography and some links to interesting sites just for your entertainment. Okay, so much for that. Thank you very much for your attention. As said, feel free to visit us, and the URL is here. Well, it is a bit small, I have to admit.